Yep. Welcome back. Uh, this time we will be proving division algorithm for polynomials over a field f. Entries from a field f, not entries of x of x has no particular field. It depends on the input that you give. It changes its field according to it. So yeah, you're given two polynomials a of x and b of x. Let me change the pen. Yeah. So you're given two polynomials a of x and b of x from this set f of x. Um, we need to prove that there exists a unique q of x and r of x such that um, b of x can be written as q of x times a of x plus r of x, such that the degree of r of x is strictly less than the degree of a of x. Now, this should imply this, but we are not interested in this, so just remove this bit. The proof of this goes by something like this, but but if this were the proof, I won't be making the video, right? I found a different proof, I guess. Easier, I think. Easier to think about. So let's go to that. Proof, basically, right? Proof. Let me change. Yep. Proof. Cliche. Anyways. Yeah. So consider first case that let me write this the the expression. B of x is equal to unique b a of x times sorry, what have I written? Oh my god. A of x times q of x plus r of x. So we need to prove that this uh, is unique. Mm, consider the, what to say, first case that degree of a of x is greater than degree of b of x. In this case, q of x needs to be 0, right? Because if q of x is not 0, then degree of r of x will be something may be greater than b of x or equal to b of x, and in that case uh, our first condition is violated, which is that degree of r of x should be strictly less than degree of a of x. So this implies a unique q of x and r of x, and in this case q of x is equal to 0 and r of x is equal to b of x. Let's go to no, second case. Degree of a of x is equal to degree of b of x. In this case, again, like let's write b of x as a of x, q of x plus r of x. Since those two degrees are same and we want this degree should be less than degree of a of x, we want the degree of r of x is less than degree of b of x. So the only possibility is, right, like make the make this, which is a constant polynomial, such that the highest degree of this one equals the highest degree of this one, and in that case the 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 only condition that Rx would need to satisfy is to fulfill the uh, gap that is created by the 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 rest of the lower order polynomials. So that is again done. So that this implies unique decomposition because q of x is unique, because q of x is such that it leads to the cancellation of highest degree terms from here and here. So this is unique. Now let's go to the interesting case, which is case 3. I think this is why we are here. Uh, so degree of a of x is less than, strictly less than degree of b of x, right? So how much more? Let's write that degree of a of x is equal to L plus degree of no wait, what am I writing, man? Plus L is equal to degree of b of x. Well, in this case, let's go to the next page. Excuse me. Excuse me. Yeah. So I'm back here. Yeah. Now, since we know the degrees, we don't actually know the degrees, but let's assume that this degree is no, not this. What am I doing, man? This degree is k. So the degree of b of x is basically k of l, k plus l. So let's write the statement again, the the decomposition equation again. So you basically have b of k plus l x to the power k plus l plus b mm, k plus l minus 1 x to the power k plus l minus 1 dot 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 dot, dot till b to the power 0 is equal to uh, a to the a a a what a k x to the power k plus a k minus 1 x to the power k minus 1 plus dot 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 till a to the power 0. I mean a 0 x to the power 0 into um, mm, some polynomial which is of degree L, because only if it is it is of degree L, it can the highest degree term can go with this to make uh, to cancel out this term, uh, and so that the degree of r of x is not um, k plus l, which should be greater than k, which should be greater, which means degree of r of x would be greater than degree of a of x. So we don't want that. So the degree of q of x would be l. So let's write q. Q is q. Well, q is q, but anyways, q of q what ql x to the power l plus dot 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 dot. I should have written more terms here and here, but anyways, plus q to the q0 x to the power 0 plus r of x. Now here comes the magic, right? You have known this. Now let's write. Let us see how the coefficient of x to the k plus l will look here. Here basically, it will look basically nothing special. Here the power k q to the power l, a k q l. No other terms will give the exponent as k plus l. Similarly for x to the power k plus l minus 1. You can check it, but you will get ql ak minus 1 plus ql minus 1 ak. I think you're seeing a pattern here, right? With 2 obviously you won't see a pattern, but if you write more you will see a pattern. um, Now the yeah, I think I forgot to tell another thing. Like all the, not just x to the power k plus l, but till like from x to the power k plus l to till x to the power k, all the terms on LHS should be cancelled by terms from these in RHS. Otherwise, R of x will have degree more than A of x, which is not intended, right? So that is what we are exactly doing. So we need this to be equal to B of k plus L, this to be equal to B of k plus L minus 1, and if you go on similarly, you will get B to the power k is equal to, what to say, A to the power k q, what do I say, uh, 0 plus A to the power k minus 1 q plus dot 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 till I think A to the power k minus L ql, right? Now see this and everything in between. It looks like a matrix equation basically, right? So you have basically b to the power k plus 1, b to the power k dot 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 till k plus l, sorry, k plus l minus 1 dot 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 till b to the power b of k, this being equated to some coefficient matrix which goes like a to the power k, I mean a of k minus 1, a of k dot 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 till a of k minus l dot 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 a of k, right? This is being multiplied with multiplied with what basically? Yeah, q to the power q of l minus 1 dot 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 till q of 0. Now if you see this middle matrix, the coefficient matrix, and you find the determinant, it will be basically a of k to the power I don't know, maybe l plus 1, and we know that a k is not 0, right? Because if a k is 0, then the degree of our ax polynomial is not k, but we have assumed the degree of our ax polynomial is k. So this is the determinant, and which is a non-zero thing, which is again debatable, but still for now, yeah, it is. So since this is an invertible matrix, the solution will be unique, right? And what is the solution basically? The solution is basically q of x. And now since q of x we have got, and it can only be a single polynomial, Rx is forced to be the the thing that is left over, right? So that ends our proof, and we have basically found that q of x and r of x is unique. So that's it. Thanks. Not question marks or exclamatory mark. Why am I? Oh my god.